Samiksha, Tony Dixon, Geeta Shankar. Hi, good evening to all of you. Okay, so today this topic is going to be permutations and combinations. Okay, so for whoever is in the 11th, I think Tony is in the 12th. There shouldn't be an issue, right? Tony, 12th, right?
Sir, 11th.
Oh, Tony, okay, you're 11th. Oh, okay, so Geeta is no problem. Samiksha, you are Samiksha, you are in 11th or 12th?
11th, sir.
Oh, both of you 11th. Oh, okay. So உங்களுக்கு இந்த பெர்முடேஷன்ஸ் காம்பினேஷன்ஸ் நடத்திருக்காங்களா?
Yes, sir.
நடத்திருக்காங்களா? வெரி குட். ஒரு நிமிஷம். ஐ எம் கெட்டிங் அ கால். an important call. Hello.
Yes, sir, we can hear you, sir.
I can hear. Okay. So the first problem, I think since உங்களுக்கு இந்த combinations எல்லாம் நடத்திருந்தாங்கன்னா it should be fairly easy. AB, BC, and CA are sides of a triangle having 5, 6, and 7 points respectively. How many triangles can be formed using these points?
Radha, I think you may have to speak only in English because one or two people they may not understand Tamil.
Okay.
Okay. Thank you.
Yeah, fine. So yeah. So this I will draw the diagram. So let's see how we can do. There is a triangle ABC. So there are 5 points on AB. 1, 2, 3, 4, 5. Let us say P1, P2, P3, P4, P5. And there are 6 points on BC. 1, 2, 3, 6. And there are 7 points on this. Okay. Now we have to form triangles. Okay, using these points, not using points A, B, and C. Okay. only using points, P1, P2, P3, P4, P5, then Q1 to Q6, R1 to R7. Using these points, how many triangles can be formed is the question. Please think about it. Any idea? So for forming a triangle, we need to pick up 3 points. So how many ways we can pick 3 points that will form a triangle, right? Come up with some ideas how we can pick up 3 points. What is the condition that a triangle will be formed? A triangle will be formed if the 3 points are not collinear. If all the 3 points lie in the same line, then the triangle will not be formed. Okay. For example, if you take P1, P2, and P3, a triangle will not be formed. But if you take P1, P2, and Q1, then triangle will be formed. Similarly, P1, P3, and Q2, or P1, Q1, R1, all those combinations are possible. So we have to count how many such combinations are possible. Okay. So first of all, tell me, there are 18 points, and how many ways we can pick 3 points? So we can see the totality of all the combinations that are possible, and then we can eliminate what will not form triangle. Okay. So how totally there are 18 points. So how many ways we can pick up 3 points from that? Okay. So there are totally 18 points, and we have to pick up 3 out of that. What is it called? From 18 points, if you have to pick 3 points, that is called 18CF. 3. Combination, number of combinations of 3 from 18, and which we write as 18C3. Okay. So if for some of you this should have been covered, the formula for combinations. So how many can recollect? How many can tell? Who can tell what is the value of this 18C3? So there is a general formula for NCR. Okay. If you want to pick up N items from, R items from N. Okay, there are N students, you have to pick up R students. So there are 10 students, you have to pick up 3. Let us say you have to pick up 3. So 18C3, the general formula NCR is N. Does somebody know the formula? No. N factorial by N minus R factorial into 3 factorial. R factorial. General formula is this. Okay. NCR equal to N factorial by N minus R factorial into R factorial. So just substitute now 18C3. Please substitute and calculate what is 18C3. So that is the total number of ways in which 3 points can be selected out of the 18. Right? Totally there are 18 points, right? 5 plus 6 plus 7, total number of points. The available 18. So number of ways in which 3 points can be chosen equal to 18C3. Okay. And I told the formula. It is N factorial divided by N minus R factorial into R factorial. Okay. And this 18 factorial by 15 factorial means this is product of all the numbers from 1 to 18. This is product of all the numbers from 1 to 15. So when you divide 18 factorial by 15 factorial, what will remain is only 18, 17 and 16. Because after that 1 to 15 will get cancelled out. So whenever there is a combination 18C3, you start with 18 and you have to write 3 numbers 18, 17, 16. And denominator will be 3 factorial. Okay. So this is the formula for combination. And what is 3 factorial? 3 factorial is 1 into 2 into 3, which is 6. So you multiply this, so you're going to get some value. 51 into 16. Another. Okay. So this 816 is the total number of ways in which 3 points can be chosen. Okay. Now, out of this, all the combinations are not going to form triangles. Okay. So which combinations will not form triangles? If all the points from P, if P1, P2 and P3, they will not form a triangle. Only P1, P2 and P4, P1, P2 and P4. So if you choose all the 3 points from either P group or Q group or R group. Okay, if all the 3 points are from the same group, then it will not form triangle. But otherwise, it will form a triangle. P and 1 from Q, or 2 from P and 1 from R, or 1 from P, 1 from Q, 1 from R. all such combinations will form triangle. Right? So what we need to exclude is only if all the 3 points are from P, all the 3 points are from Q, R. Okay. So how many will be excluded? I'll put them as collinear points, collinear combinations. Huh? So how many ways in which 3 points can be chosen from this 5, P1 to P5? Suppose you've chosen all the 3 points from P group. How many such combinations are there? That will be 5. How many ways in which you can choose 3 points from 5, right? 5C3. And the formula for 5C3 is, there is a formula whenever you see something like 5C3, where 3 is fairly bigger. Okay, we can simplify it using a formula NCR equal to NC n minus R. There is a formula NCR equal to NC n minus R. So whenever you see something like 5C3, we can convert it into 5C2. Because 5C3 is equal to 5C2. Why we should do is because this is easier to calculate. Like I said, no, it's only now 2 terms, 5 into 4 divided by 2 factorial. Whereas here we have to write 5 into 4 into 3 divided by 3 factorial. These two will give the same result, but this is easier to calculate, right? So 5 into 4, 20 divided by 2. This is 10. So this is one set of collinear combinations from the P group. Similarly, from Q group, that is going to be 6, right? 6C3, same way. Here we cannot simplify, because even apply the formula NCR equal to NC n minus R, you will get again 6C3 only. So you have to do like 6 into 5 into 4, 3 times. 6C3 means you write 3 times. And then put 3 factorial at the bottom. 3 factorial is 6. 1 into 2 into 3. So that is 5 into 4, 20. Similarly, collinear for R group, 7C3. So here it is already, the 3 is smaller number. If you apply the NCR equal to NC n minus R, you are going to get 7C4, which is more complicated, more difficult. So you leave it like this itself. So 7 into 6 into 5 divided by 3 factorial. Six gets cancelled, so you get 35. So you have to exclude this 10, 20, and 35, which adds up to 65. So of all the combinations that we calculated, 816, 65 combinations are going to be collinear, so they will not form triangle. The rest of the combinations will all form triangles. Okay. So therefore, number of triangles possible. So that 816, right? 816 minus 65, which is 1, 1, 5, 11 minus 6, 5, 7. 751 triangles can be formed. Okay. Is that clear? Tony and Samiksha, are you able to follow? Yeah, I see that Geeta is good with this. Yeah. What about Tony and Samiksha? Yeah. Okay, good. Okay, so I'm going to go to the next problem now. Okay, so I want to take up this problem. Based on the principles that we just now saw, I put the problems in groups. Okay, so that after I do one problem, you can do one problem. Okay. This is similar problem. Okay. In an octagon, how many triangles are possible so that no side of triangle is side of octagon? Again, let us draw the diagram. What is an octagon? Octagon will have how many sides? How many?
8.
Okay. 8. 8 means it will be like this. Okay. So let us say A, B, C, D, A, B, C, D, E, F, G, H. Okay, now we have to connect these points A, B, C, D, E, F, G, H in such a way to form triangles. But in the triangle, the side of the octagon should not be one of the sides of the triangle. So we have to form triangles so that the side of the octagon does not become a side of the triangle. So then if in that way, how many triangles are possible? For example, if you take points A, H, and E, it will form a triangle, but it has got the side which is overlapping, right? So side of the octagon is becoming side of the triangle. So that should not be counted. Okay. But if you take A, G, and E, let us say A, G, and E, okay, that will form a triangle, right? A, G, and E.
Adjacent points should not be taken.
Correct. Correct. Adjacent points should not be taken. Correct. So like that, how many triangles can be formed? I request you, it's similar, right? Like Clark's problem. So I want you to think about it and come up with some solution. Okay. Please work on it. Tony, Samiksha, are you getting any ideas? Geeta?
I am getting a small idea. அதாவது 3 vertices consecutive like AHG, HGF, GFE அது மாதிரி consecutive 3 vertices எடுத்து போட்டோம்னா அதெல்லாம் வரக்கூடாது. 3 vertices consecutive இருக்கிறதும் வரக்கூடாது. 2 vertices consecutive இருக்கிறதும் வரக்கூடாது.
Yeah, speak in English, ma.
Yes.
I think there are some
Okay.
people.
So,
Not from
three consecutive vertices, there are 7 possibilities, and 2 consecutive vertices, there are 8 possibilities. After that, I don't know what to do. So, in a triangle, maybe we have to remove this.
Okay. Again, let us adopt the same approach. What about Tony and Samiksha? Any ideas? This is similar to last problem, where now, in how many ways we can total number of triangles that can be formed? How many ways is the total number of ways? Let us calculate first. How many?
Same as the previous 800 and something, the 8C3.
Here, how many points are there? So we have to pick up
8 points.
3 points.
Any 3 points
any 3 points out of this, how many points are there totally? 8, right? A, B, C, D, E, F, G, 8 points are there, and we have to pick up 3 points. So in how many ways in which we can pick up 3 points out of 8?
8C3.
8C3. Let us calculate that first.
That we did in the previous problem, so it is 816.
The previous problem also it was 8C3, is it?
Yes.
Okay. That was 18C3.
Oh, sorry.
Okay. So, number of ways, total number of triangles that can be formed. Okay. Combinations of 3 points. Out of 8. So in how many ways we can pick 3 points out of 8? (8C3). So what is the formula for 8C3? 8 into 7 into 6.
7 into 6
3 numbers,
1 into 2 into 3.
3 factorial at the bottom. 6 gets cancelled out. 56. So that is the total number of triangles that can be formed, including those for which a side is octagon. So we are not excluding anything. So if you do the total count, it is 56. Now, you see in how many triangles the side will become side of the triangle octagon also. Okay. Let us say we take AH, okay, AB, let us say AB. With AB, including AB, how many triangles are there? ABC, ABD, ABE, ABF, ABG, ABH, right? So those triangles will all have AB as a side, correct? So, you all agree? When you take AB, there are going to be how many triangles using AB as a side, as one of the sides? We can connect that AB with any other 6 points, right? So that means there are going to be 6 triangles like ABC, ABD, ABE, ABF, ABG, ABH. Okay. like AB க்கு அவ்வளவு. அதே மாதிரி BC is also going to have how many triangles? 6 triangles, right? Similarly, CD. With CD as one of the sides, there are going to be 6 triangles. ED also 6 triangles. EF, GH, and so on. So, using those 8 sides, so number of triangles that can be formed. The side is included. So for each side, 8 sides, there are 6 such triangles possible, right? So what is this? 8 into 6 is 48. Okay. So now, is it? Can we exclude all the 48? Then will we be okay, or anything wrong in this? Now, you take this triangle ABC. We have counted it when we took AB. Okay, we counted when with AB as a side, we counted 6 triangles. BC as a side, we counted 6 triangles. But in the process, this triangle ABC has been counted 2 times, right? But a triangle like ABD will not be counted 2 times because that has got only one side. ABD will be counted only once. But triangles having sides like AB and BC, BC and CD, CD and DE, they have been counted twice. So how many such triangles are there? That we have counted 2 times. It's easy to count, right? AB and BC. That is triangle ABC, triangle BCD, triangle DEF,
7,
EFG.
7,
Count it properly.
because I counted having 3 consecutive vertices, so it came to be 7.
Check again. See, AB and BC is 1. Then BC and CD is number 2. CD and DE number 3. DE and EF number 4. Then EF and FG number 5. FG and GH number 6. Then GH and AH number 7. And AH and AB number 8. 8 are there, right? Where 2 consecutive sides are included. 2 consecutive sides, there are 8 such combinations of 2 consecutive sides. That is what we have double counted. Okay. So that means in the number of triangles where side is included, we have to exclude 8 because out of this 48, 8 are double counted. Okay. Similarly, right? 8 times the number of triangles where 2 adjacent sides are included equal to 8, double counted. So that we'll have to exclude from this 48. Okay. So then we have the triangles where a side is included, correct number of triangles. Then now if you subtract it from the total, you will get the number of triangles where side is not included. Okay. 56 minus 48 minus 8. So how many you are getting? 58 minus 40. So that is 16. So there are 16 triangles. Okay. Well, these problems need some thinking. Okay. Obviously, your JEE problems are not going to be, very easy ones. Okay. So we have to apply some thought process. So if you have done a couple of problems like this, if you observe and understand this, 3 similar problems you should be able to do. That is the idea. Okay. Shall we move on to the next problem? Let's do this. Oh, I missed that problem. Okay. This is simple application of the formulas. We saw the formulas for NCR. It's simple application of that formula and simplifying factorials, because these are going to involve some factorials. So that is testing of that. Okay. So please look at this problem. This is problem number 3. Okay. If n plus 1 CR plus 1 is to NCR is to n minus 1 CR minus 1 is 55 is to 35 is to 21, then find 2n plus 5R. First you find out n and r. From this you can find out n and r. Okay. Because 2 ratios are given. N plus 1 CR plus 1 is to NCR is 55 is to 35. In NCR is to n minus 1 CR minus 1 is 35 is to 21. So from that you are going to get 2 equations in n and r, so which can be solved. You can determine n and r and calculate 2n plus 5r. Okay. So apply the formulas and I'll do this problem because again there are 2 problems like this. So yeah. So I'm going to do the first one. Okay. And ask you to do the next problem. Okay. Actually, this also you can do because since I have told the formulas, does anybody want to try? Then I will wait for some time. Tony and Geeta are the only 2 people remaining now. Tony, Geeta, do you want to try this?
Yeah, I can try.
You can try. What about Tony? We know I've already written down the formulas for NCR, so you have to just apply that formula for n plus 1 CR plus 1 and minus 1 CR.
Shall we take only the first 2 and the last 2 separately?
Yeah.
Okay.
That will give you 2 different equations, right?
Okay.
Tony, can you try? Tony, are you there?
Yes, sir.
I'm asking, well, can you try this or shall I just work it out?
Sir, trying, sir.
Okay, try and tell me. Yeah. Okay, I think you should have written at least the first formula. What is n plus 1? CR plus 1?
I arrived at the first equation.
Okay, let's hear from Tony first.
Okay.
Tony, can you tell me what did you write for n plus 1 CR plus 1?
Sir, n plus 1 factorial divided by r plus 1 factorial into n plus 1 minus r minus 1 factorial.
Very good, very good. So n plus 1 minus r minus 1 will be n minus r nu போட்டுக்கலாமா அத? Is that right? N plus 1 factorial by n minus r factorial into r plus 1 factorial. Okay. So this is equal to 55 by 35. Sorry. This is your n plus 1 CR plus 1 is to, what is NCR? Is this correct? There is a simplification that is possible here. Dividing by 5, we can make it into 11 is to 7. So these two can be written as ratios also. So this is to this equal to 11 is to 7 means this by this equal to 11 by 7. So let us do a division on both sides. N plus 1 factorial by n minus r factorial r plus 1 factorial divided by, I put into reciprocal, right? Now can you do any simplification? What can be simplified here? You can simply see, right? N minus r factorial here, n minus 1 r factorial here. So these can be cancelled, right? What else can be cancelled? If you cancel n plus 1 factorial and n factorial, what will you get? Where? The numerator or denominator? Can you tell me? Tony or Geeta?
Yes.
I'm asking n plus 1 factorial divided by n factorial. What will that be?
Yeah, we can separate. We have a formula. Like n plus 1 factorial is equal to the bigger number, n plus 1 into n factorial.
Right. So because this is n plus 1 into n minus 1 and it's going to go on up to 1, and so this will get cancelled out. All the remaining terms are going to get cancelled out and you're simply only going to get n plus 1. Right, Geeta? Is that what you're saying?
Yeah.
Tony, is it okay?
Yes, sir.
Okay. Same way for r factorial, r plus 1 factorial, what you will get? R plus 1 in the denominator. Same way, right? Because r plus 1 factorial is r plus 1 into r factorial. So your equation is n plus 1 by r plus 1 equal to 11 by 7. So what equation can you get? Simple first degree equation, linear equation you can get.
7n minus 11r equal to 4.
This is your first equation. In the same way, write down the second equation.
Shall I share that? I have worked it out.
Have you done that, Geeta?
Yeah, I got the answer.
Okay, good. Let's wait for Tony.
Okay.
Tony, can you write down the second equation in the same way? Second equation is NCR by n minus 1 CR minus 1 equal to
35 by 21.
35 by 21. So this can be again simplified to 5 sevens are 35, 3 sevens are 21, 5 by 3. So write the formula for NCR. Write the formula for n minus 1 CR minus 1. Straight away I'm writing in a reciprocal manner. Right? So what does it lead to? N minus R get cancelled. This n and n minus 1, you get n here. So n by r equal to 5 by 3 or 3r, 3n. 3n equal to 5r. 3n equal to 5r is what we are getting. The second equation. So the first equation is 7n minus 11r equal to 4. Second equation gives us 3n equal to 5r. So you can simply substitute. So n equal to 5 by 3r. So 7n equal to 7 into 5 by 3r. So 7n minus 11r equal to 4. So now you see a fraction. So multiply the whole thing by 3. So that will give us 35r minus 33r 12. It's 2r equal to 12 or r equal to 6. Okay. So substitute r equal to 6. So n equal to 5 by 3r. So what you get is n equal to 10, r equal to 6. Is that what you got, Geeta?
Yeah.
Okay.
Same.
Tony? Are you able to follow?
Yes, sir.
Okay. So then what we have to find out? 2n, what 2n? Plus 5r. Find out 2n plus 5r. $20 plus 30, which is 50. So this is your final answer. Okay. Is this clear?
Yes, sir.
Okay. So let's do this next problem. Okay. So I want you to do it. Okay. All of you, both of you to do it. Okay. Find the range of value of k if n minus 1 CR equal to k square minus 8 into n CR plus 1. So again, in the same way, substitute the formulas and find out what is the range of values of k. Solve for k now. Please do it. If you come to some stage, please tell me. First, substitute and see what you get. So here you're getting basically k square minus 8 equal to n minus 1 CR divided by n CR plus 1. What is this n minus 1 CR by n CR plus 1? Simplify it, and that is your first step.
I get r plus 1 divided by n.
R plus 1 divided by n. Okay. Tony, did you simplify? Are you getting the same answer? Let's put it down. I don't hear from Tony. So, okay. So this is n minus 1 factorial divided by n minus 1 minus r into, I am putting it in the reverse, reciprocal. N factorial by right. I'll see that this gets cancelled out. So again, r and r plus 1 r factorial, r plus 1 factorial, they get cancelled out, and you get r plus 1. This gets cancelled out, and you get n. So now what do you see? K square minus 8 equal to r plus 1 by n. So range of possible values for k is going to be dependent on what is the range of possible values for r plus 1 divided by n. Okay. So R is always smaller than n in NCR. Okay, the maximum it can go is up to n. Okay, R cannot be more than n. Okay, so therefore you can take this as this can range from 0 to 1 only. Cannot be 0 because this is r plus 1 by n, because r cannot be negative. So it cannot be 0, but it will be less than 1, but slightly more than 0 it can be. Because when as r goes, n can be any value, r can be any value. They are not given anything, any constraint. So we can go on increasing r, okay, and n. So that means we can go maximum up to 1. And
how can we try to see values for r and n?
it can be anything. They are not given anything, right? They are not given any condition for n and r. What can be the values of n and r? So therefore, we have to only take that, since r will be less than n, r plus 1 by n, maximum value it can take is up to 1. But 1 included, okay? And 0 is not included. So you put, the range will be 0 to 1, 0 not included and 1 included. Okay, so this is based on the how that NCR works. In NCR, R is always smaller than n. Okay. So you put like this now. Okay, 0 less than k square minus 8. Find the range for k.
An inequality. Solving
Inequality. Yeah.
When we take square root, we should consider plus or minus both values.
You add 8 first.
On both
so it becomes
sides.
8.
Okay.
So if k square is ranging between minus 8 and 8 and 9, then k will be ranging from root of 8 to root of 9, plus or minus both. So that means it will be minus of root 8 to root 9, minus of root 9. Okay. Whereas this is a square bracket, this is a whole bracket. Union. So it will come like that. Okay. So here actually, since this is smaller, so we'll have to put it the other way. So this is minus 3 to 2 root 2. This is right, minus 2 root 2. So if in a number line you can see this is 0. So you have minus 3, minus 2 root 2. This is your 2 root 2, 3. So if it has to be in this range or this range, then its square will be between 8 and 9. Because even if it is minus, then the square will become plus, no? It will, this square of this is going to be plus 9, the square of this is going to be plus 8. So anything in between, it is going to be between 8 and 9. Similarly here also. So that is what I have written. But please note that this minus 9, that is a square bracket, and 8, the 2 root 2 is a square bracket. Is that okay? Okay. So I think we will wrap up today now. Okay. So there are we'll do more problems next week. Okay. Better come prepared, better prepared. Okay. So read your book. Like I said, I always keep saying, read the book, read the examples, and come. And work out your school book exercises. Okay. So without doing that, if you come and sit here, you're not just going to be sitting and listening to me. Okay. So please come better prepared. Okay. I want more participation. Okay.
Thank you so much, sir.
Okay. Okay, Maggie. Okay. Thank you all. Bye.
Hmm.